2019 linear motion. Question 1b. Train A and train B are on parallel tracks traveling in opposite directions. Train A starts from rest at minute and accelerates uniformly at 0.5 meters per second towards lead clip to a speed of 25 meters per second. It then continues at this constant speed. At the same time, train A is leaving minute, train B passes through lead clip, heading towards minute at a constant speed of 30 meters per second. 3 minutes after leaving leak slip, train B starts to decelerate at 0.25 ms to the -2 and comes to rest at minute. Find the distance between minute and leak slip. Okay, so we've two things happening here. A is leaving, it's at rest and it leaves, accelerates, and it goes like this. So we have a graph that looks like this. And train B is going at a constant speed and then decelerates and comes to rest. So I think we have enough information with B to find the distance between the two. He's going 30 meters per second and then 3 minutes later, so he's going at 30 for 180 seconds. So in meters, that's going to be 5,400 meters. Then he decelerates at 0.25. So we have A is equal to 0.25 or minus 0, it's deceleration, minus 0.25. We don't know the distance. We want to find the distance that he travels within this period. He comes to rest. So my final velocity is 0 and he started at 30. So using the formula v squared is equal to u squared plus 2as, we should be able to get an answer for s. 0 is equal to 30 squared plus twice minus 0.25 by s. So what's s going to be? That's 0.5 s going to the left, so it's going to be 900 divided by 0.5. Set s is going to be 1800. And that's the total distance then, 1800 plus 5,400. So the distance between the two towns must be 7,200 meters. Part 2 asks at what distance from minute do the trains meet? Okay, so let's have a look at A here. If we can find out how long it takes to get to this speed, what speed does it get to? 25. We'll know whether they meet somewhere along this line or do they meet along this line. I'm assuming it's somewhere along this line here. So for A, we have this velocity is 25. It starts from rest. The acceleration is 0.5. And we want the time takes to get there. And this is my time down the bottom here. So time is equal to t. So v is equal to u plus at. So 25 is equal to 0 plus 0.5 t. So you can see it's going to be 50 seconds. T is equal to 50 seconds. So that's how long it takes A to get to here. We know we can use the area under these graphs to find distance. So we've got speed, time, and distance. Speed, time, and distance. So if we look at just let's check how far B has gone in this 50 seconds. Well, he was 180 seconds at 30. So he's only gone 50 by 30, which is 1500 in the time it takes A to get up to top speed. So we know that it's along this line then that they're going to meet. So if we look at the distance, and we also know in these questions, so let's just say this is the 7,200 and B is going in that direction and A is going in that direction. Wherever they meet, if they meet at this point, the two distances are going to add to 7,200. If they meet at this point, it's the same. So distance 1 plus distance 2 when they meet, or distance A and distance B, has to be equal to the total distance. So we need to get both. We need to get an equation for distance for both A and B. So A at this point is going to be half the area of this triangle is half the base by the height. So that's 25, 25 is 625. And if we take this one as t, this one here, the total time, it's already traveled 50 seconds up to here. So this one is going to be t minus 50. area of this rectangle then is going to be 25 by t minus 50, which is 25t minus 1250. So the distance for A, the distance that A has traveled, is going to be these two things combined. So we said 625 plus 25t minus 1250, which is going to be 25t, not 2t, 25t minus 625. And the distance for B, if they're going to cross over, we said at this point that this is going constantly at 30. So the distance for B is 30t. So SA plus SB has to be equal to 7,200. So this will allow me to find the time. And then we can just put t in here and we'll get the distance from minute, because it's from minute. It's going in this direction from A. So 25t minus 625 plus 30t equals 7,200. So 7,200 plus 625 is going to be equal to 55t. So bring the 55 underneath. And that's going to give me a time of 142.27 seconds. And if we put that in up here, t is equal to 142.27. The distance that A has traveled from minute is going to be 25 by 142.27 minus 625. And typing this into a calculator, we're going to get 2931.75 meters. That's the distance from minute at which the trains meet. Part 3 of this question, you're told that after traveling 25 meters per second for a while, A decelerates to come to rest in leak slip 36 seconds after B stops in minute. So we need to know how long it takes B to get there. So B traveled for 180 seconds and then started decelerating. And the deceleration was 0.25. So it was traveling at 30. It decelerated at 0.25 seconds. So the time taken is just going to be 30 by 4, which is 120 seconds. So that's 180 plus 120. So 300 seconds for B. So we can say then that A takes 300, well 36 and 336 seconds in total. So we just look at this speed time graph again. It traveled for 50 seconds. That is a terrible straight line. Better, even though it's not great. And then decelerates like this. So we take this as t. Total t is going to be 286, isn't it? Yeah, 286 and 50 is 336. So this one becomes, well, let's let this one equal t. And then this one from here to here is t 286 minus t. So we can work out, we have an unknown t, and we can find t, the time taken to decelerate, 25 over t, this is 25 here, 25 over t will be the deceleration. So we need to find t. So we have the total distance is 7,200, so we can use the area of 1, 2 and 3. So half 50, this is number 1, half 50 by 25 is the area of the triangle. 286 minus t times 25 is the area of number 2, and the area of number 3 is half of t by 25. So we simplify this down. We had that already with 625. So 286 by 25 is 7150 minus 25t, and that's plus 12.5t. All has to be equal to 7,200. So what have we got? We've got a minus 12.5t, so we bring that across, make it plus 12.5t. So that's going to the right, if you imagine that. And coming to the left, we have 7775 minus 7200. 7775 are these two, minus 7200. So that's going to give me 12.5t equals 575. So the time taken to decelerate, that goes in 46 times, 46 seconds. So my deceleration, 25 divided by 46 as a decimal, will be 0.54 meters per second squared. So that's this question complete.